5.2 is about standard deviation. So we're going to be learning about how we find the standard deviation. So the arithmetic mean is what you know as the average. In statistics, we use X bar to represent arithmetic mean. And we read this as X bar. And so how we find this is we add up all the data. So we find the sum of the data. And then we divide by the number of data. If you want it in fancy statistics symbols, we find the sum of all of our x's and divide by the number of data. So again, this means, let's do green, sum of data, and n is the number of data. The concepts of the variance and the standard deviation are probably not as familiar to you. So these are two new words, variance and standard deviation. So I'm going to look over here at them, variance, standard deviation. And in statistics, we use what's the Greek symbol sigma squared for variance. So we read this as sigma squared. And then the standard deviation is, oops, I wanted to do that in purple. Sigma. So variance is sigma squared, standard deviation is sigma. All right, let's go ahead and we're just going to do an example so we see how we find this. And the key thing is that they tell us how spread out the data points are. So how far away are the numbers from each other? Let's look at some example data. Two students were in the same psychology class at Clearwater University. There were 10 quizzes taken during the semester. The students' quiz scores were as follows. So here we have one group of quiz scores, here we have another. And the question I want you to think about right now is, what do you think has the lower standard deviation? So when I'm thinking of lower standard deviation, we're thinking of numbers are not as spread out. Oh, sorry, you can't see that. And hopefully you're thinking that student 1 and the justification, the quiz scores are closer together. So now we're going to calculate the mean, variance, and standard deviation for student 1. Calculate the mean. And the mean is where we find the sum, that's our X bar, as we did up top. And it's the sum over the number of data. So find the sum of our student 1 We should get 850. And then how many data points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. All right, so that's our mean is 85. Let's go ahead and complete the below table, and this will help us find the variance and standard deviation. So here I read X bar. What is X bar? X bar is our mean. So let's write that down here. We're going to write 85, 85, 85, 85, all the way down. Now we're going to do X minus X bar. This is X, this is X bar. So we can think of this as column 1 minus column 2. So 85 minus 85 gives me 0. 82 minus 85 gives me -3, and so on and so forth. Go ahead and fill those out. You should get 5, 4, -3, 5, -1, -4, 2, -5. All right, this last column says we're taking our x minus x bars. Where do I take my x minus x bars? That's these numbers. So this piece right here is column 3. And then we're going to square it. So we're going to do 0 squared, which is 0. -3 squared, which is 9. 5 squared, which is 25. So we take our third column and we square it. Notice, since we're squaring it, when we square a negative, it becomes a positive. So all of these should be positive. All right, so let's look over here. Our variance, so that's sigma squared, is, go ahead and write this, x minus x bar squared over n. Now, before this notation freaks you out, what does this mean? We're going to add column 4. Because what has my x minus x bar squared? Column 4. So let's add that up. What do we get? So 0 plus 9 plus 25 plus 16 plus 9. You should get 130. And how many numbers do we have? 10. So we get 13. So that's our variance. And then standard deviation is the square root of sigma squared. Or we could think about it, the square root of the variance. What was our variance? 13. And go ahead and plug that into your calculator and we get 3.6. So let's kind of go over this again. First column, this is our data. So notice we had our list of data, 85, 82, 90, and we just listed all right here, 85, 82, 90, all the way down. Then we have our mean. This is saying I'm doing my x's from column 1 minus my x bar. So column 1 minus column 2. This one says I'm taking that x minus x bar, so I'm taking these numbers and I'm squaring them. Our variance is the sum of the x minus x bar squared. So we're going to add up column 4. So we're going to add all these. We got 130. We divided it by 10 because there's 10 numbers and got 13. And for standard deviation, we took the square root of 13. The square root of the variance. Now go ahead and pause the video so that the students can do the exact same process for student 2. Now that you've had time to do it, let's go ahead and walk through it really quickly. I'm going to go quicker on this one. We have to find the mean, variance, and standard deviation. So first of all, for the mean, x bar is, we're going to add all of our data up, and we should get 770 over, there's 10 data points, so our mean is 77. So we're going to go ahead and put 77 all the way down. And now this says I'm going to take my x's minus my x bar. So 58 minus 7 is negative 19. 92 minus 77 is positive 15. And we keep going. Column 4 says I'm taking the x minus x bar. So I'm taking column 3, these numbers, and I'm squaring it. So you should get 361, 225, 49, 64. All right, so for the variance, so sigma squared, we add up the fourth column and divide by n. So when I add up the fourth column, I got 2,880. And we have 10 numbers. So it's 288. And so my standard deviation, I take the square root of the variance. So I get 17.0. Notice, the standard deviation of our first one was 3.6. This one was 17 because the numbers are farther apart. Bigger because student 2 scores were farther apart. All right, let's look at this next question. How many scores for student number 2 were within 1 standard deviation of the mean? So let's go ahead and underline those words. 1 standard deviation of the mean. Well, what's our mean? So we're going to look at our mean, and we're going to look within 1 standard deviation. So plus 1 sigma. What was our mean? Our mean was 77. and we're going to add and subtract 17. So we're looking for 77 plus 17 is 94. 77 minus 17 is 60. So how many are between 60 and 94? And there should be 6 of them. All right, summarize what you discover when you compare the standard deviation of the two students' quiz scores. Well, standard deviation number 1 was 3.6. Standard deviation number 2 was 17. And pretty much what I'd said earlier, student number 2 has a larger standard deviation because it is more spread out. All right, last question. Summarize what you discover when you compare the ranges. So how do we find range? We take our high minus our low. So this is, so range 1, the high was 90, the low was 80, so that's 10. Range 2, go ahead and find your high and your low. Hopefully you saw that the high was 99, the low was 45, so that's 54. So you can say something similar. Range 2, higher, or student 2 has a higher range. Because the scores are farther from each other.